record to this. Okay, so today, like I said, I'm going to take a little bit of a different approach. And instead of writing a bunch of stuff, I'm going to go through the code listings and ask you, what's going on? What do you understand? What don't you understand from the code listing? Because I know sometimes you type them in and you just type them in. It's like, okay, it worked. Maybe I'll need it. Maybe I don't. And you don't ever ask or something. So I'm going to go into your sharing screen. Let's see, 9-1. All right, so these pointers become really, really important. And in 162, we start pointing to memory addresses all over the place. We keep finding places and making that connection, and we point to them. So this chapter 9, along with when we talk about structures, are huge for 162. So this first one, 9-1, it's nice and simple. We have our traditional in line 8 integer X declaration. We know somewhere in memory there's 4 bytes, and this number 25 is stored as a whole bunch of zeros and ones or represented in hexadecimal or something. Now, if I actually wanted to find the address of that, I would throw the ampersand in front of it. And this is going to tell me where is that located. Now, that might not seem important right now, but where it's located is something that we're going to be linking up later on down the road. Also in line 11, they throw something in here and say, hey, what's the size of X? And it should come up as 4 bytes. So size of is a function that's tucked away somewhere. If you ever wanted to use it, you could. But in line 10, that ampersand X, it shoots me the address and baby steps. Okay, so here's the ampersand again. But first, we go to line 8, and I'm actually declaring something called a pointer. PTR is short for pointer. So we are creating a variable that is going to hold an address. Right now, we're going to set it to null pointer, which is a common thing you'll be doing for the next 2 semesters. Okay. PTR, again, holds an address. So when I see this ampersand X, I know I'm going to store the address where X is at. I've stored it temporarily in pointer. And if you ran it, you should have probably have seen where it prints something out in hexadecimal. Now, if you get me for 230, you're going to do a bunch of stuff with number systems, base 2, base 8, base 10, base 16. We're going to have that all over the place. In this third one, kind of the same thing going on. But if I look at line 19, I'm doing something called dereferencing pointer. And that means I'm going to go to the address that's stored in PTR. And when I throw that asterisk in front, it says, hey, I'm able to change the value that's stored there. So if you look at all the documentation and everything that goes along with these, that should be somewhat straightforward. Questions? They're moving right along. Addresses. When I look at numbers, even though it's the name of my array, numbers, numbers, stores an address. That's what it is. It's an array with an address, and then what goes in subscripts is what you take to the first 4 bytes, then the next 4 bytes, and so on and so on. So if I don't have any numbers after it, and I look at line 10, that asterisk numbers, it's taking the first element and it should have displayed a 10. So far, so good. All right. The next one, we're going to start looking at an array because an array and pointers both have addresses and work really similar. So if I look at line 8, I'm declaring an array of integers and size of 5, and everything I would do to work through filling the array and then displaying the array. Nice and simple. Old school from chapter to, I don't know what chapter, 7 maybe. Now we can change this completely. Before I go anywhere, look at line 15. Instead of saying numbers sub count, so instead of saying numbers sub count, where are my square brackets? There they are, sub counts. I'm doing dereferencing the address plus count. Now that count, even though it's going to be 1, 2, or 3, it's actually taken 1 times 4, or 2 times 4, or 3 times 4. So it's allowing me to move over that number of sets of 4 bytes at a time. Same thing down below. So if I had you write a program with arrays, you could replace everything arrays that you see on the right side with everything using pointers that you see on the left side.
Could you go back to the other pointer example because I wasn't able to get um the code listings for the pointers things to work, and I was just wondering if it was something wrong
Okay.
with my
Which
code.
number? I have
Um,
1, 2, 3, and 5 up that we looked at already.
any
Okay. So if
all
I go
the
to 3,
let me just take a screenshot of that.
yeah,
Come on.
where are we going?
Hold on, my computer is opening t 10 million things at
Oh,
once
yeah.
because I just opened it again. Stop.
In the name of love. Oh, that's an old school song. How about your phone, Jack? You want to take it with your phone? Or did you get it?
Got it. Thank
Okay.
you.
Okay. So in number 5, we looked at. In 6, we looked at how we're using dereferencing the memory address plus an increment that is going to be times 4. Number 7, I am in line 8, implicitly filling the array
T.
with those values. I have a declaration for a pointer to a double. We can point to all types of different things. It's just giving me storing the address at the beginning location. Okay, notice in 13, I have the pointer. It's getting the address of the array name. It's getting so double pointer, which is a pointer, coins, which stores the address, are the same things. And if you take a look, this first loop, lines 18 to 20, we print out the array. If you take a look at the second loop, 26 through 28, we print it out using pointers, the dereferencing so we can get the value at coins plus count location. I do like our textbook. The guy does give a lot of good examples. Line number 9, we have null pointer. Num pointer is a pointer to an integer. Right now, it's pointing to nothing. It's pointing to ASCII code 0. It's pointing to null pointer. It's pointing to some languages want you to use capitals NULL. 0 works fine if you ever wanted to do that. Okay. Now, the first loop is going through this array and going 5, 10, 15, 20, 25, 30, 35, and 40. Where are we right now? Well, as I went through this array, my pointer gets set and it's sitting at the very end, the very last memory location for the very last item. Well, now this is kind of cool. In the second loop, I go backwards. It's printing them in reverse. So I keep subtracting 1, or basically 1 times 4 bytes, so that I can keep going in reverse. And again, we're giving you a really broad right now of pointers, but later pointers are going to become really important. This is good. This is where we struggled early on when we were doing our prototypes, our function calls, and our function headings, and how they were all slightly different. Well, code listing 1911 is giving me, what do I have going on here? Function prototypes. I'm calling in line 14. I am sending in an address. Ampersand number is an address. Down here in 17, I'm sending in an address. Ampersand number. Why am I sending in the addresses? So it allows me to be able to change number. If I just sent in number, it would come back and be the original value. Starting to tie all of this stuff together. This reference variable gives me the address, the array
Professor,
name. Yes, Lisa.
am I understanding this correctly?
Yes.
Okay,
Yeah.
you are using the addresses to get the numbers from the function prototypes or the array. That's what the address actually does is it holds that address to get the numbers from these other co-
So in this problem right here, we don't have an array. We're
I
just
see that.
working. We're, right.
But,
Okay. Do you want to go back one? So here,
well, what I'm understanding is we hold the address and when we hold the address, we're holding the address for the array or a number that a user would type in, correct?
yes,
Okay.
yes, yep. So lots of different addresses we can get. The address for, like you just said, something that's stored. What's the beginning position? Old school, and you're going to see this later. Before we had strings, we had C strings, and we worked with addresses. Okay, so let's take it and let's up it a little bit. This time we have an array called sales. Line 16, sales is the address. It's a little different than when we had X because we had to pass in ampersand X. Say, I want the address at X. Sales is the address at the beginning of the array. Okay? Here it is again. I'm sending in the address. So I can come in here and I can work with it as an array. I can use the actual array.
Sorry, I crashed
Same
again.
Same thing down here in 47. I can work with the address. This time I'm using array, dereferencing it, adding that value to the sum, and I'm adding one to it. That line 54 takes the address where we are right now in array and adds, what's a double? 8 bytes. It will add 8 bytes each time. Looking at 913. Oh boy. Line 10, I create an array called an array. Line 12, I have a second array. Line 15, I call a function display values. I'm sending in array 1, which means I'm sending over the address. I'm sending over the address of array 2. That's two different up here. Scroll down. I have one function. It's called display values. And I'm going through using pointers to display the values. And what are the values that are displayed? Well, what was the trick in this 913? The word constant. Constant, even though I'm passing the address in and working with it, is going to say, no, 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 no. I'm still overruling. I have the final say. You cannot, you will not make changes to your array. Questions? From the
I'm
videos.
still not able to get the pointer thing to work. Whenever I declare the pointer as null pointer, it does not allow me to do it.
Okay, make it 0. You muted yourself, Jack, but make it 0 and see if that helps. Okay, so next. I'm gonna go here and I had all the notes. We went through the notes. The one that I wanted to point out was down here. I want to view speaker me, and here's what we have. Different things. The first group is dealing with arrays. How do I do the prototype? Hey, it's an integer array. I'm passing in an integer. How do I do the function call in the main? Good job, Jack. I pass over the address of the integer array. I need to create a local variable in the heading that will receive that address. So the address of values, let it be known that there will be an integer array, is now stored in array. So I know it's going to be an array of integers. We had a little trouble with that when we wrote the program 2 chapters ago. Once you see it, it becomes laid out. How do I do the same thing with pointers? I have a declaration of a pointer. I have an address and I'm storing that address, but I'm going to work with pointers. Okay, so what I would normally do is, where is it? That's not the bad, that's not good, that's not good. Have us now write a program. And the program is this one right here. It's on page 553, number 2, but I'm sort of just going to dictate what's going on. And if I said to you, I'd like you to write a program, ask for the number of scores. Okay? We would probably call a function to fill the array with the scores and, throw one of our sorts in. Again, we're just passing in the array. What we don't have to really ask for the number of scores because if we do, we'd have to pass them in. But we could skip that first line and let's say there's going to be 10 scores. All right. So we could skip this and say there's going to be 10 scores. Otherwise, we'd have to pass in the size. So this with arrays, not too bad recently. Calculate the average stored in a double and then display. Display the array and display the average. Not too bad, right? Well, what I want you to do today is I want you to write this program with arrays and then save it. And then I want you to redo this program, but instead of arrays, so number 1 is this, number 2 is this, and the number 2 is no arrays, no square brackets for subscripts. This way, you're going to get a side-by-side comparison of how we would do it with arrays and how we would do it with just pointers, only pointers. So once you get this one done, it's going to be kind of easy to convert over to get to this. And I'd rather this first time you do the conversion instead of just trying to, unless you're up for it and want to just go get it and try it that way, I'm okay with it. But this was um, a good start as far as notes are concerned, how to write the functions working with these pointers. Are there any questions? Oh,
So
crap.
what are pointers useful for?
And so in the next, in your next class, you're going to say, I want to store a bunch of numbers, but I don't know how many there are. How big of an array will I need? A lot of times we don't know. But just like vectors, we're going to learn about doing something dynamic where I'm going to create a structure, which we don't know about, and I'm going to store a value in it. And a structure is two part. And then I'm going to have a pointer so that I could go to another memory location. And I can so it's similar to the concept of vectors, but once we learn this idea, and it's called linked lists, once we learn about linked lists, it opens up this vast world of how I can search, how I can sort, how I can work with trees, all these different new data types. And it's kind of cool once you get the hang of what you're doing and how these linked lists work versus dealing with an array. And again, an array is static. We only can fill whatever memory we have. A linked list is dynamic. A lot of times an array is easier to work with than a linked list. So it's like you bounce back and forth. But we're getting everybody ready for 162. That's why I'm saying at 161, you start to struggle. You're getting by. You're not putting the time in. You're really going to be hurting in 162. So this is a class of 19 and 161. And by 162, maybe out of that 19, there'll be 9 left. Because I'll still lose some of you in this class, and then I'll lose some of you in 162. So this, give these topics their due diligence. Everybody good with this? Got a picture or something? And everybody's got the name of the 4 functions: fill array, sort array, calculate average, display. Display is going to display that new sorted array plus what the average is. Then you're going to change these 4 functions and write a similar program, but you're not going to use arrays. We're going to do everything by way of pointers. I know some of you typed this up real quick while I'm showing it, and I want to make sure we are good to go. Questions?